We present COLiER, the first groupware for real-time collaborative editing of raster images in a web browser. It enables multiple users to interactively create collages of images and apply image processing techniques to these. We start with a brief demonstration on how our application works. This is our web application COLiER. It uses similar UI elements as other image editing programs. On the left side, we have a toolbar where we can select different tools. And on the top toolbar, you have further settings for each tool. On the right side, we have additional social features such as downloading or sharing. We have also included a chat option where you can communicate with other partners. Next to it, you have an overview on who is currently working on this project. Here we have a layer overview where you can change the overall order or adjust visibility or locking. When you select a layer, you can see more properties below. By clicking the VCA tab, you can add additional effects and also adjust them by clicking on them. You can also directly manipulate the layer on the canvas. During the whole session, I can see in real time where my partner is currently working on. Here we can see his mouse pointer. In the layer panel, we can see that he is currently on the background layer. Now he has added a new layer. He has now exclusively locked the layer. This way only he can work on it. For all other users, this layer is locked. Okay, now we can see that he is transforming the layer. We can also see when he changes the layer. Here we see a new effect that he has added on the layer. With the brush tool, we can draw on our selected layer. We can change the size and the color. We also get live updates on the drawings of our partner who is drawing a cloud. So with this application, we can simultaneously work on the same project. To understand whether our strategies regarding communication and synchronization achieve the desired collaborative possibilities, we performed a post-deployment user study. Participant groups were asked to perform 3 tasks that cover the main functionality of our editing system. For the first task, we provide a blank background layer and a second layer containing a coloring book template. The participants were asked to color the template using the brush tool. The users are encouraged to use multiple brush colors and also create their own doodle using additional layers. The task's objective is to test if users are able to work with layers, use the brush tool effectively, and detect potential synchronization conflicts. All the participants were able to perform this task quite easily and were satisfied with the system performance. For the second task, we provide the users with a set of disarranged puzzle pieces, each represented as an individual layer. The task is to rearrange these layers using rotation and translation in order to solve the puzzle. The task objective is to test if users are able to use layer transformation tools simultaneously and effectively. Colored lines show which user selected a layer. After understanding this hint, users were able to solve the puzzle efficiently without trying to manipulate the same layer. For the last task, the participants were asked to create and adjust new layers in order to create a collage collaboratively. In addition thereto, they are encouraged to apply different image effects to each layer. The task objective is to test if users are able to reuse their learnings from previous tasks and also make them familiar with blending and layer modification through our provided set of image effects. As you can see, they got creative and learned to exploit the functionalities of our application. Some brief notes about the technical background of our system. We developed a simple client-server architecture based on Node.js. The application and the image rendering is performed client-side to avoid possibly high update latencies, since this would limit the usage of the real-time experience. The server only stores and updates the document information as well as broadcasts messages between the clients. Let me show you how exactly the synchronization between all clients work. Since all users can potentially work on the same project, resulting data conflicts are required to be handled properly. After the user changes a parameter, a change request is sent to the server over the synchronization service. The service also listens to all change events from the server. If the request is accepted by the server and the document is updated, it will notify all clients. The service then modifies the store and the user interface is updated accordingly. The user is not allowed to update the local store directly to prevent version conflicts. A small update delay is barely noticeable because of the small message sizes. Thanks for watching.